Hi, everyone. Thanks for attending this last talk of the day. Hope you are enjoying JCON 22. Who am I? My name is Sergio del Amo. My blog is sergiodelamo.com, so it should be an easy enough domain. I am in Twitter as well if you need me. I am involved with the Micronaut Framework, which is a JVM framework, an open source JVM framework since its inception in 2017. I am doing Micronaut developer lead here at a company called Object Computing. Object Computing is the main sponsor of the Micronaut Foundation. The Micronaut Foundation is an organization which supports the framework, pays my salary, and helps spread the word about the framework and develop the framework so that it essentially fits the goals of the community. We have other great sponsors of the Micronaut Foundation, such as Microstream, whose technology I'm going to talk today about. And we have other sponsors such as Safari.net, Visor Games, or Gradle Enterprise, or JetBrains. So many thanks to the Micronaut Foundation sponsors, and many thanks as well to the JCON sponsors for making this conference possible and for inviting me. I want to have mostly like a live coding demo, so I don't have any slides almost. So let's see how this goes. So I have, I know that during the conference there have been talks, and there will be talks about Microstream, and hopefully you are excited as I am about Microstream. But what I wanted to show you is, so Micronaut has integration with Microstream, and you can use Microstream as your persistent layer for a Micronaut application. So I'm going to show you like a Micronaut application which currently doesn't use Microstream, and explain you essentially what it will mean to use Microstream. And hopefully you can see that it's quite easy and as appealing as you become as excited as I am. Without further ado, I'm gonna show you first the app without using Microstream. So I'm gonna start my previous demo, and I'm gonna go here to my computer, and I'm gonna, all the code sample that I show you is saying GitHub in a repo that I will share with you at the end. So no need to take notes. I have the chat here open, so if you need to ask me any questions, I will be hopefully able to answer them. Also during the talk, don't hesitate to wait until the end. So what I'm gonna do is I'm gonna run DynamoDB, because I'm going to show you this application using a different persistence. So this application has a module and allows me to like run the application using DynamoDB as a persistent engine, hopefully if Docker starts. And I'm going to go ahead and run the app. The app seems easy, and it's easy enough, but it has many things, and hopefully you are excited when you see it. So this is like kind of not like a Hello World application, but an application with some logic. So I'm going to run the app. This is a Hello a to-do application, so it allows me to create to-dos and delete to-dos, but it has other things. It has, for example, security. It has configured like an it using Amazon Cognito to configure like an OpenID connect flow. So when I enter and click login, it's gonna redirect me to Cognito. I have to enter my credentials and go back. It's gonna have like a cookie with my JWT token. It's gonna use that token to authenticate me. So let me show you to you. So I'm gonna run the app, and I'm gonna you see here the interface says login here on the top. I'm going to click. This is redirecting me to Amazon Cognito. So this is no longer in localhost. This is in Amazon Cognito. I'm going to enter here my user. So this is the same flow that you will get, for example, when you have like a Micronaut application which uses signing with Google. I'm going to click sign in. This is going to do the OAuth handshake. And I have here now a token signed by Amazon Cognito in a cookie, and in each request the cookie is sent, and thus I am authenticated. You see here my email address here, rendering the view. This application is rendered server-side HTML, so this is not like a front end, like a real front end or anything. This is server-side HTML. I am using Bootstrap to style it up, and I am using a fancy, not a fancy, I am using a Turbo, a Hotwire Turbo, to essentially get kind of a single page application responses, but without using any front-end framework, just Turbo streams. So if you have not heard about Turbo, that's a quite interesting integration that we have in Micronaut, but this is probably for another talk. And what I'm going to do also is I'm going to open a different browser, and I'm going to show you that this application is also using WebSocket to connect. So if I go here to Firefox, so on my right, I have Safari. On my left, I have Firefox. I'm going to authenticate here as well. So I have to authenticate because this is a different browser. And I have to open one password and do Micronaut to do. And copy the password and paste the password. Hopefully. And click sign in. If my app responds. There you go. So I'm authenticated, and I'm going to create here a to-do. I'm going to say learn about Microstream. And you saw that the browser on the right, on the left, got updated automatically. And that happened via WebSockets. So this application is hosting a WebSocket server as well. And when I delete an item here on Safari, it's going to send a WebSocket message to delete that from the front end. So as you saw, pretty simple, but pretty slick. So it has server-side HTML, WebSockets, security, persistence here with DynamoDB. So how can we add a persistent layer using Microstream? And you will see that this is going to be, in comparison with the DynamoDB code, quite much simpler because we're going to be on the Java realm. So let me stop the application. And what I just executed was this application called AppNet DynamoDB. And as you see, this is a multi-project built-in Gradle, and this is including a folder called repositories Dynamo, which is the implementation of these repositories that I have in Java for Dynamo. And what I'm going to do is, and it's also like importing some DynamoDB things as well. So I have another folder called here AppNet Microstream, and this is just it has the HTTP WebSocket server and the Microstream repos. And if I go to the Microstream submodule, it has a dependency to repositories, which is yet another module which defines these interfaces called to-do repository. So I have here defined implementation for the 3 repositories that the application uses. So we have a repository for saving to-dos, a repository for saving users, and a repository for server WebSockets. So we are not going to use the other 2 in this when running locally, because the other 2 are more thought when you like register with Cognito and you get with the callback and we save the user, or when we use this sample application can be deployed also to AWS Lambda, and we use Amazon API gated WebSockets to like get to use their WebSocket API and get like the WebSocket sessions. So mostly what we are going to be working is with the to-do repository. To-do repository is an interface, a Java interface. It's using so Micronaut supports a subset of the Beam validation specification. So this is using the standard annotations for verifying that a string is not null or not blank. Is also using the standard annotation to verify that this object is a valid object. What does it mean to be a valid object? So this is a class, Pollo in Java, which has an issuer, subject, and email. So this is the representation of the currently authenticated user, and it has like not blank, not null, etc. So nothing fancy. It has some final fields with constructors, some getters, and equals and hash code implemented. So Pollo, nothing that you cannot have in your applications. So how can we implement this with Microstream? And let me show you the implementation with Dynamo in comparison. So I have here a a bunch of DynamoDB logic to define my primary keys, my sort keys. I have like a DynamoDB repository with the actions for saving the DynamoDB table. So a bunch of logic that, as if you were like using a relational database, you will have something similar. So a bunch of logic to save to a table in Dynamo, etc. And I have like representation for the keys in Dynamo. So not 3 lines of code. So I have some code to persist all of that in Dynamo, and I am using in Dynamo a single table design. So I'm going to show you that with Microstream, we are going to have like a persistent layer, which is more performant because it's going to stay on the Java. It's not going to do an HTTP request to go to Dynamo. And hopefully with Micronaut, it's going to be quite simple to use it. So what I have done is I have the code and I have deleted the code. So what I'm going to do is I'm going to revert the commits, and I'm going to show you the commits and talk about them. So the first step is to add the dependencies. So we are releasing Micronaut 3.7 today. Micronaut 3.7 includes the latest version of Micronaut Microstream, and that version updates to the latest versions of Microstream. And that version is, let me show you. So that's why I'm forcing the version. So Micronaut ships with a BOM, a bill of materials, and that's going to be the version included in the BOM. Maybe I can even remove it for now. Just show it to you. Try that. So we are shipping, we have as a transitive dependency Microstream storage. So I just got downgraded. So let me just specify because I am using what version of Micronaut I am using. I think I wanted to show you like using the latest version of Micronaut, which is going to ship today. This will work with Micronaut 3.6.3. So I'm using 3.7 snapshot because I just wanted to use this as an opportunity to do like a smoke test that everything is working in 3.7 before we release. So Micronaut stream, the latest one, so 7.1.0.0, and you don't specify that dependency directly, you specify Micronaut Microstream. Another thing that you have to do is you have to specify an annotation processor as well, because we're going to do some logic at build time to do like AOP, because we are going to simplify the way you work with Microstream with the usage of annotation. So pretty simple to work with. You add 3 dependencies to your code, nothing fancy. If you are new to Maven, this is API means it's kind of a compile dependency that you're exposing upstream. I could have set this as implementation as well, but yeah, I wanted to add it upstream in case I wanted to like access those classes in the other module that is consuming this dependency. So I have my Microstream dependencies. I'm gonna do a commit so that I am able to revert the other commits. So I'm gonna say add back dependencies. So the next step for us is going to be to add, so Microstream is a persistent engine that uses a graph. So, and because it's a graph, you need like a root instance. So you are going to have like an object to be like kind of the entry point of our graph. So I'm going to do that. I'm going to create an object, which is going to be the root of my app. And I'm going to call that object root data. You could have called it whatever. And here you can create the Java structure that you think is more performant for you. So all my to-dos, they have like a unique identifier. And the to-dos are assigned per user. So each user has his own to-dos. So I have my to-dos like learn Micronaut, learn Microstream, and someone else may have like their to-dos like learn, I don't know, Project Reactor and learn about GraalVM. So what I have done is I have a map The key is the user unique identifier. In this case, it's going to be the subject, the claim subject. And then I have like another map, which is the map of to-dos. So this is going to be the to-do, the unique identifier of the to-do and the to-do object. So kind of a map to like make me easy to retrieve, because remember the interface. So we have like an interface called to-do repository. And if you remember the interface, we have like, we want to be able to delete the to-dos of a particular users identified by the particular unique identifier. We want to save a to-do and associated to a user. We want to be able to find all the to-dos of a particular users, and we want to find like a to-do by ID. So I thought that a map would work well for me, but Microstream is flexible. This is Java. You can maybe model this in a different way. And I have another thing for modeling the other two interfaces, the user repository and the WebSocket connection repository. I'm not going to go into detail for that because I think it probably make more confusing, but you will have all the code if you want. And I have created a getter for both maps. So I am exposing this via getter. Before I show you the implementation, let me show you the Microstream config. And in the Microstream config, one cool thing about Micronaut is that we support. So the configuration I'm going to add to my application.yaml. And this is going to be here under appnet source Microstream. And we support in a single Micronaut application, you can have multiple instances of Microstream. And what we do is we create like a name qualifier for each of those instances. So I have used here to-dos. You could have used here JCON if you wanted to. So this is like the name qualifier. And one thing that you want to do is you have to specify the root class. So this is kind of the root of your entity graph. And as you saw, I specify the class that I was showing you before. So the package, the fully qualified class name with the package. And then Microstream is quite flexible how you want to store the data. So I'm going to use the simple thing to do, which is store the things in a folder in my computer. So let me actually go to this folder. And so let me just shut down DynamoDB because I don't need it. So I'm going to go to the root folder of my user, and I'm going to delete the to-dos folder if I had one. So I'm going to save that. So that way we will see that the data is being created there. But you can also like use, you can like, instead of persisting to this, you can persist even to Dynamo in the example that we were like discussing. But for this demo, I think persistent to disk is going to be probably a good option. We support all the configuration that the Microstream configuration describes. So actually, we are using their classes to configure. So the same thing that you will find in the Microstream documentation is here available for you. And yeah, as I said, you can have multiple instances. I only have one, but you can have multiple. So let me show you how you will. Let me show you the implementation of to-do repository. And the first thing that you see is this is a singleton, and we have this API called root provider, and you can inject the root instance of your entity graph by using the root provider. You specify you specify here the root class of your application, and root provider is a functional interface. Actually, it's quite simple. It has like a single method called root, and you can like get access to the root data. So this is what you will inject in your Micronaut components. This is part of the Micronaut application context or the Micronaut bin context. And Microstream has a rule which I'm gonna actually go to the documentation and actually read it out loud to you, because that's probably for the best. So I'm gonna go to, let me actually go here to docs.micronaut.io. And if you scroll here, you will find the Microstream documentation. And the key when working with Microstream is this rule. The object that has been modified has to be stored. To store a newly created object, you store the owner of the object. And this can be a bit confusing when working with maps, but hopefully it will make sense. So what I'm going to do here is I have the implementation of the delete method here. I am getting the root object by using the root provider API. So this is the root data object. I'm calling get to dos. You remember this is the getter that gets me the map of users to dos. I am checking if the unique identifier for the user I'm thinking is the subject claim in the JWT. So I'm checking if the user has to dos, and if it has to dos, I am attempting to delete the to do identify by delete. And here, this is the first thing that is going to simplify with Micronaut is you can add an annotation called store return. And as the annotation says, this will attempt to store whatever you are returning in this method. So because I have to actually store the map of the users to dos based on these rules that I just told you before. So remember, the object that has been modified has to be stored. So the object that we are modifying is the map of the users to do. This is the one that has to be stored, and this is what we are returning in our code. So this is normal Java. So I am getting access to the users to do, and I am removing the one. So this is a map of with key, and so this is the map of a string to do. So I am removing the to dos with this unique identifier, and then I am returning the users to do, and this is what Microstream will store. If this is confusing, I will show you how you can use the Microstream REST API to see actually like a user interface of your persistent engine if you want. And I will show you how to write tests with Micronaut and Microstream. So there will be no excuses. I mean, if it's confusing, this is going to be really easy to test it and see it. How about the save? So in the save, I'm checking if we already saved like a to-do for this particular user. If we did, we call append. If we not, we call save. And append and save, they use different things. Save uses a store params, which is similar to a store return, but doesn't store the return type, but the parameter named to-dos. So we are storing this parameter when the method ends. Both methods, the ones annotated with add store return and add store params, they are synchronized. So we are modifying this map, and this is a multi-threaded application, but these methods, they will be synchronized. So here I am adding this entry to the parent map for the user with actually like a map of one entry for now, one entry with the to-do key and the to-do ID. I am returning this for convenience, but what I am actually storing is the store params. So as you saw, this is quite simple to work with Microstream. You tell Microstream what to store, and you work as you will normally use work with Java. And here, for example, when for the find all for the find ID, I don't have to specify anything. Where I am working with the regular Java code. So I am getting like, I am checking if this thing exists. If it doesn't exist, I return an empty list. If it doesn't exist, I return here an empty optional for find by ID. And I work with the regular Java API for optional or for a stream that we are used to. So really powerful to just search in memory. And this is all the implementation for the API. So nothing, as you saw, this is a simple Java class. The only thing that you have to be careful is for the store return or the store params annotation to essentially understand which object do you have to save. And once you get hold of that, the then we are good to go. So let me see. I think I should be able to run the application with. So just to recap, I added the dependencies for Micronaut Microstream. I added the configuration for Micronaut Microstream, telling which was the class that is going to be used as my root class. And I also implemented the to-dos repositories, and I decorated some of these methods using this store return annotation or store params annotation. And with this, I'm going to be able to run app Microstream, which is an application which uses a Microstream for persistence. And let me just, before I do that, I don't have like a to-dos folder here on my user. So I'm going to just run the app. And hopefully the demo gods are with me. We will have persistence using Microstream. So I think the app should be up. I think I removed the info log level, so that's why we didn't see the startup. So the app is up and running. Let me show you if I have now a to-dos folder. I do, and this is the contents of my to-do folder. So this is where Microstream is going to persist the data of my application. And I'm going to add here like learn Microstream. And this thing was saved. And as I did when I first encountered Microstream, the first thing that you will probably do is, if I stop my application and I restart my application, will the data be still there? And hopefully it will, if I have configured everything correctly. And if not, we will troubleshoot it and understand. And I have just refreshed my browser and the data is there. So the data, the persistence worked as we expected. So it persisted to disk. And when we shut down the application, the Microstream instance shut down. And I can, the same work with as I showed you before. So we can have like a different browsers, WebSockets, magic, like about Micronaut. So you see that the browser refreshed on the right. I can delete things. So really nice, really simple to implement persistence. What else do we have in store for you with Micronaut? So Micronaut supports the concept of endpoints. So if you come from Grace or from Spring Boot, you probably have heard about actuators. That's the same idea. And we have like a health endpoint, which is like a health check of your application. So what I'm going to do is I'm going to come here and I'm going to add actually, let me do it let me just do the JCON commit, use JCON as main qualifier. So I'm going to add the management dependency by reverting the comment. Actually, I could have done this directly. So what I just did in the commit is just I added this dependency. And in the moment you add this dependency, by default, the health endpoint will be enabled. So if I run my application now, let me actually do put this in info again so that we see the startup. So we see when the app is ready. So Microstream engine is starting on the startup. So I can do now cal -e localhost health. We are not going to see much fancy, but that the application is up and we are okay. And in this moment, it was when you see like the Microstream storage foundation class being engaged. So this is when we initialize that. Micronaut by default, the beans are loaded lazily. You can change that if you prefer to load everything eagerly, but beans are not loaded until they are needed, included singletons. So what we are going to do to see more details is I'm going to expose the health endpoint. I'm going to say log back info. I'm going to expose the details of the health endpoint. And I'm going to do that by reverting this commit that I did before to delete it. So I'm going to come here and in application.yaml, I have here endpoints health details visible anonymous. So what this is going to show is this is an application that uses Micronaut security. So what I am telling is that I'm going to show the details of the health endpoint to any user, even if you are not authenticated. So I'm going to run the app again. And I'm going to hit the health endpoint. Let me see if I can. And this is the response of the health endpoint now with details visible. And as you see, a Micronaut Microstream is contributing a health indicator and essentially is telling us that this is up. And yeah, if you have multiple, you will see like multiple. You see the JCON key here. If you have like 2 Microstream instances, you will see 2 entries here. So this is the health endpoint, has also the disk space, etc. So yeah, integration of Micronaut Microstream with the health endpoint is out of the box there. If you have the management dependency in your class path. So what else do we have for you? We have a really nice thing, which is Microstream. They provide a GUI, and if you go to, let me go to the Micro docs because I have a link to the Microstream documentation. So they have this this GUI. This is the Microstream documentation, the client GUI, where they distribute as a fat jar, and you can run it and connect to a Microstream instance. So what I'm going to do is a Microstream instance that exposes a REST API in a format that they define. And what we have done in Micronaut is that the Micronaut has an extra dependency called Microstream REST, which will expose an API such as the one that the GUI client is expecting. And thus we will be able to connect and see the API. And this is especially useful in development. This is actually thought only for development. So you will see that you're going to have to like explicitly enable it because we want that you don't have this enabled in production, because otherwise you will like be exposing your whole persistence storage. So what I'm going to do is I have downloaded this jar file to my computer, and I can go here and do a java-jar, and I have placed it here in this folder called applications. And I have here Microstream, and this is the server port 808080. You probably don't see because of Zoom, and neither do I. So hopefully this thing started in port 808080. So if I go here to localhost 808080, this thing starts and is telling me to connect to an instance. So let me add the Micronaut Microstream REST dependency so that we are able to connect. So I'm going to add the Micronaut Microstream REST dependency. So I'm going to go to build.gradle here in Microstream. So let me just click it here. So I added this dependency. Again, I am forcing the version for now. Tomorrow, you will not have to specify the version to use the latest Microstream because 3.7.0 will be out, and that will be the version of the bomb. So I have Microstream REST. If you remember, this is an application that was secured. So I have added configuration to essentially enable anonymous access to all of those endpoints. So I have anonymous access to, and I could probably use placeholder to have less configuration, but I have added configuration to have that all of those endpoints be completely open. They don't require like a JWT or an authorization header or anything like that. And the last thing that I have to do is I have to come here and do Micronaut, Microstream REST enable true, because this will be by default, by design, disabled by default. So you have to be explicit about enabling it. And I'm going to run it. And because we don't want for you to run this thing in production, we are going to actually show you like an ugly warning here, telling you that be careful, that this is that you are like running Micronaut Microstream REST in your application. So yeah, that's a good warning to have, so that we don't forget to remove this. This is just a tool for local development. So what I'm going to do is I'm going to try to connect to this instance. So the GUI expect by default the Microstream import 4567, but my application is running import 8080. So I'm going to click connect. This is configurable, and we support even because we support multiple instances. You can have like multiple API endpoints per instance. I will go back to the question in the chat in a second. So we have here this is going to connect to my Micronaut application, which is exposing the Micronaut Microstream REST API, which is the Microstream client is able to consume it. And as you see, I have here my to-dos. I have one item in my instance, and if I add another item, like another one, and I click save, and I reload here, I should see it here saved. So this is really useful when you are like working. I will see two items here. So this is the first map is the user subject, and these are the other two. So there is a question in the chat which says the Microstream root, the map is not synchronized. What about multi-threading, or have I missed something? I probably say it too quickly. So when we are modifying the map, we are doing that in these methods in the save, in append, and in save, and in there's another delete method here annotated with a store return, and a store return will execute this synchronized. So if you go to the Java docs of those annotations, they will tell you that essentially the equivalent of this thing is that if you run this thing with exec execute synchronized, so the contents of those methods will be synchronized. So yeah, as you said, a Micronaut application is multi-threaded, but we kind of take care of the boilerplate of synchronization in those applications. So this is showing the how easy it is to write like AOP with Micronaut. Microstream creates Micronaut crew starter for. So there's another question in the chat. Micronaut CRUD starter coding with Microstream. So we don't have like a CRUD, but I'm gonna show you a couple of things. So we have 2 ways to generate a Micronaut application. One is Micronaut launch, and another one, as the colleagues were saying, is to use the Micronaut CLI, and I can do here create app. Sorry, let me just quit here and do mn Microstream foo. And if I do here mn create, and I do Micronaut application Java I can select a Microstream feature. And I can select Micronaut Microstream, Micronaut Microstream REST, or Micronaut Microstream Cache. The same code that powers the CLI powers the web application. So I can select here also the Microstream features. So I can select Micronaut Microstream. Actually, this is preview, but we have to remove the preview. So I can select not the cache. I will tell you more about cache in a second. I can select the 1, the 2. And this will add these 2 dependencies. So it will add the annotation processor dependency for Microstream, So it will add you the necessary dependencies. So, and it will add actually Micronaut Microstream as a REST development only dependency. I don't think we generate any configuration. To learn more, we have to get started also with Micronaut Microstream. We have a Micronaut guide. So if you search for Micronaut Stream here, we have using Microstream persistent with Micronaut in the 3 languages and the 2 build tools. So this is a kind of a step-by-step guide, which will do a similar explanation of what I just showed you today, but in a written format. And you can download a complete solution here by clicking the download link here on the top of the guide. So hopefully this answered the Frank remarks in the chat. So just for local development, I saw you like the Microstream GUI client connecting. The last thing that I want to show you is a test, because the best thing, the GUI is nice to understand what's going on. But the best thing to do is to have a test. And because Micronaut starts so fast, it's really nice to write tests for your Microstream logic. Enable REST. Let me do a commit and revert the test that I wrote before, which is here. So if I go and I search for to do a repository test here, so I have a test and I am creating a temporary directory. I'm going to be saving the Microstream data in a temporary directory in the test. So I am creating the Micronaut application context, and I will be closing it at the end. And here I create the Micronaut application context. As you see, I am passing to the application context as a method called run, which takes a map of properties. And in the map, I am passing Microstream storage to do a storage directory, and I am passing the path to the temp folder, and I am passing the root data. So this thing that I am showing you just here is the equivalent that we did in the application YAML, if you remember. So you can supply similar configuration, but in the test, and because Microstream does everything like in memory, and you can write to this, you can like create a temporary directory, which you can do easily in JUnit 5 or in Spock. So I'm creating a context, I am getting the to-do repository. So if you remember, the to-do repository is an interface. So I'm telling the Micronaut bin context, give me a bin of this type. I am creating a mock user, and I am generating a unique identifier for the to-do, and I am saving the to-do. I am testing that the thing is there, and it is easy to be there because this is in memory. So if I forgot to add the Microstream annotation, this thing will be there, right? So let me explain you what I mean. So if I comment out this thing, if I came here to my class and I forgot the annotations, right? So if I forgot, or let me comment, if I forgot the annotation, let me comment them out for now. This test will still pass, right? Because the thing will be in memory. But what we want to test is that when we stop the application and we restart it, the data is still there. So if I run this test, the test will pass. And what we want is the test to fail, right? So the test is green. So what I'm going to test is when I close the application context and I create it again, and I get the bin repository, I'm going to verify that the data is still there, and now it's going to fail because I commented out the annotations. And this is really powerful because this allows you to test that your logic for saving things with Microstream is correct. And as you saw, this is blazing fast. This is like running in less than a second, and I am like compiling the test and everything. So the test is failing, but if I now add back my annotations, so if I do multi-line select and I run them, the test will be green. So I'm gonna uncomment the rest of the test where I am testing that I can like add multiple items, and I am testing that I can delete items. So a test that will test the whole thing. There you go. So complete end-to-end test of Microstream and Micronaut working together. And that's pretty much what I wanted to show you today. So what I showed you is the steps to use Microstream in a Micronaut application. So first step, you add the dependencies. Then you add configuration. We support multiple root classes. So we will support multiple Microstream instances in a single Micronaut application. You configure the root class for your Microstream instance. And then you can use several annotations that we have at your disposal to make it easy to work with Microstream. If you don't want to use the annotations, that's fine. We support also, it's in the Microstream module documentation. You will see an example. You can inject the store manager directly if you prefer to do that. So it's not necessary to use our annotations. Hopefully I show you today that using the annotation is a bit easier because you don't have like to use you don't have to take care about the execute synchronized. We will do that for you. I showed you that you can enable the health endpoint easily. It is if you have the management dependency, which is automatically there. I showed you how you can expose the REST API and consume it from with the Micronaut GUI client, and I show you how to test. And the last thing that I'm not going to show you, but I'm going to tell you, is that you can use Microstream as a cache provider. So Micronaut support many implementations for our cache module, and one of them is Microstream, and it's really nice because you're not going to have to do almost anything. You're just going to have to configure your cache, and you can just use as you use any other cache implementation with Micronaut. You use the cacheable annotations and cache put, etc. And the nice thing is that because Microstream is persisting, upon application restart, the cache will be still there, right? So yeah, that's you can use both. You can use Microstream as your persistent engine, as I showed you today. You can use Microstream as your cache layer, or both. So that's completely up to you. I think I have some time for questions. Not much time, probably. Are there any other questions? And I'm going to paste a link to the code that I showed you today. Let me just fetch it and paste it in the chat while we get some questions. So the code that I showed you today is in that repo, include the persistence using Microstream. If there are no questions, thanks everyone for attending. I know the last talk of the day is always hard, so thanks everyone.